Yeah, so let's do this one. Integral 100 minus 6x squared y dA and r negative 1, positive 1 for y. And yeah, so let's just evaluate this both ways just to see. I guess I could have done it with the other one, but just to see that it does work. So on the one hand, this is, if we do the x's first, it'd be 0 to 2, 100 minus 6x squared dx dy, and then negative 1 to 1. What do we get? We get negative 1 to 1. The x's first, that'd be 100x minus third power 2x cubed y from 0 to 2. And that gives me 200 minus 16y. Right? Does that sound right? So we integrate that with respect to y, so we have 200y minus 8y squared. So from negative 1 to 1, we've got 200 minus 8 minus negative 1, so it'll be negative 200 minus 8. So that'd be negative 208, so it'd be positive 208. It's 400, isn't it? 200 minus 8 minus negative 208. I believe it. Okay. There we go. All right. So if we do the other way, just to see that it does come out the same, that'd be do the x's second of all, so do the y's first. 100 minus 6x squared y dy dx. So that turns out to be 0 to 2 with respect to y. We've got 100y minus, that'd be y squared, so it'll be 6 divided by 2, so it'll be 3x squared. So that turns out to be 100, equals 0 to 2, be 100 minus 3x squared, and then plugging the minus 1, so it'll be minus 3x squared, again. Yeah. Turns that into a positive 100, positive 3x squared. So yeah, drop out. We just have 200y, 200x, 0 to 2, that's, okay. Yeah, which way is easier?
They did a couple examples here, and the first time they did it, it looked a lot easier. The second time they had to use the formulas a lot more.
Yeah. Sometimes it's easier doing it one way than it is the other. This one, didn't make much difference. Pretty easy both ways. All right, now, here's another one. Let's see about the integral 0 to 1, 0 to 2, xy cubed over x squared plus 1. Went ahead and just put there's some in the homework where they they go ahead and just give you the double integral. You don't have to choose which way to go. In this case, it's y first integration, then x second. Okay, so looks pretty bad, but I'm just integrating with respect to y on this first one, so isn't it? I'm just thinking. Since the x's are held fixed, first of all, for this one, it's just integrating power rule, right? So this is 0 to 1 x over x times do that from 0 to 2. And so we plug the 2 in, we get 16 Now integrating that with respect to x is just a substitution. Let u be x squared plus 1. du then is 2x dx. So dx is du over 2. Now if we change, this is in terms of x, if I change over to u's, if x is 0, then u would be 1. If x is 1, then u would be 2. So do that here or wherever. All right, so 4x over u and du over 2x. Just 2 over u du, which is from 1 to 2, so that's 2 times the element of 2 minus 3 times the element of 1, so the element of 0. So it's 2 ln of 2, or in the power would be 2 squared, so ln of 4. Okay? All right, now, the other thing to note here that we could have done is notice when I made this step right here, notice that I separated my original f of x, y function into a function of x times a function of y. So in this case, I don't think any of the other cases I've done could I do this, but notice that my function, original function, could be separated into a function of x times a function of y. Well, it turns out in that case, here's what we can do. If you've got an f of x, y that can be written as a function of x as a function of y, in other words, you can separate them into x's and y's, product, and you're integrating over a rectangular region, because we'll take a look at next time where y may depend on, the region where you integrate with respect to y may depend upon x. So this, yeah, it may not be a rectangular region. Yes, we will do that next time. But turns out then your integral from a to b, integral c to d, f of x, y, or vice versa, that equals the integral from a to b. c to d h of y. And so what that allows me to do, let's go back and revisit that one. What was it? 0 to 1, 0 to 2, xy cubed over x squared plus 1, dy dx. Turns out we can separate those, so we can go the integral, what was it? X over x squared plus 1 from 0 to 1 y cubed from 0 to 2 dy. That's what that tells me. So what that would allow me to do is kind of do 2 at once, like you said. That would be 2 at once. Because here I can just do my new substitution on this. Let's see, that would turn out to be 1 to 2 again. 1/2 of 1 over u to u. So I wind up with 1/2 the ln of 2 minus 1/2 ln of 1. Multiply that by 2 to the 4th, 16 over 4. So we have 1/2 ln of 2, that's 0. ln 1 is 0, times 4, which is 2, times ln of 2. So it just may save you some time because you can just integrate. But again, it has to be perfect setup, I guess you might say, for you to be able to do that. So you got to be careful with that one.